Hello everybody. Today we're going to talk about measuring variability. One way to measure the variability of a distribution is the range, and the range of the distribution is the distance between the minimum value and the maximum value. That is, range is equal to the maximum minus the minimum. We also have something called quartiles, and the quartiles of a distribution divide the ordered data set into 4 groups, having roughly the same amount of values. For groups, quartiles make sense because quart means 4. To find the quartiles, we're going to arrange the data values from smallest to largest and then find the median. The first quartile, or Q1, is the median of the data values that are to the left of the median in the ordered list. The third quartile, or Q3, is the median of the data values that are to the right of the median in the ordered list. And the interquartile range, I'll probably say IQR, is the distance between the first and third quartiles of the distribution. So in symbols, the IQR is actually Q3 minus Q1. And we're about to do an example of this, so these are a whole bunch of words, but we're going to turn this into something a little bit more explainable. So let's do example number 10, an offensive explosion. So during the 2013 NFL regular season, the Denver Broncos had an offensive explosion, setting a new NFL record for total points in a single season up to that time. I believe it has since been beaten, by the way. Over the course of 16 games, the Broncos scored 606 points. The number of points the Broncos scored in each game is given below along with a dot plot. There's actually not a dot plot here. I lied, so I'm going to cross that off. So what we're going to do is we're going to find the range of a distribution. So we're actually going to put these all in order first, and then we can actually find everything all at once. So what we have here is we're going to first look for the lowest number, which is 20, and we're going to arrange these 16 numbers in ascending order. So we have 20, 27, 28, 31, 33, 34, 35, and I believe we have 2 37s, so 37, 37, and then we have 41, and then, we forgot to cross out a 35. Oh, there's 2 35s here. Hold on just 1 second. It's a good thing I went back and checked. So we have 35, 35, 37, 37, and then we have 41. Now we're all back caught up. Then we have 45, and then we have 49. Then we have 2 51s and a 52. I'm just going to make sure again that I have all of these numbers crossed off, seeing as how I made a mistake the first time. So we should have 16, 2, 4, 6, 8, 10, 2, 4, 6. So I do have 16. Okay, so the first thing we're going to do is to find the range, we're going to take the maximum value, which is 52, and we're going to subtract the minimum value. So we find the range is equal to the max minus the min. In this case, it's 52 minus 20. So that means that the range is going to be 32. Okay, and it's actually 32 points. Always try to use context in your answers. So the next thing we're going to do is we're going to find the IQR. And to find the IQR, remember that that is Q3 minus Q1. But first we need to find out what Q1 and Q3 are. And to do that, we actually have to find the median. Now, because there are 16 games here, 16 digits, okay, what we're going to do is we're going to find the middle of that. So in the middle of an even amount, there's going to be 8 on one side and 8 on the other side. So 1, 2, 3, 4, 5, 6, 7, 8. Our median is going to be between 35 and 37, so our median is 36. Now you could have also added 35 and 37 up together and divided by 2 to find the average, but it's very clear that 36 is the number between 35 and 37. Okay, so now that we have the median of 36, we now have 2 halves, and we need to find the median of each half. Okay, those will give us our quartiles. So we have 8 numbers on the left side and 8 numbers on the right side. So we're looking for the numbers in between the 4th and 5th number in the first half. So if you look here, there are going to be 4 here and 4 there. So the number between 31 and 33 is 32, and that is our first quartile. So Q1 is equal to 32. Now we're going to look at the right side. We have 8 numbers here, so we're going to look between the 4th and 5th number over here, and we have the number between 45 and 49, and the number between 45 and 49 is 47, and that is our third quartile. Now we're going to go back down to IQR over here. So we have Q3 minus Q1, so we're going to have 47 minus 32, and that's going to give us 15 points. Now, you may be asked to interpret the IQR in context of the question. So in this case, this means that the range of the middle half of the scores for the Denver Broncos, see, I'm using context and bring it back, is 15 points. And this is interpreting the IQR in context of the question. So what you can actually do is if you have to interpret this for another set of data, I'm going to underline words that will change, but you can basically use the same sentence format. So the range of the middle half of the context for the Denver Broncos is your IQR. So this is going to be the IQR, and this is going to be the context. Everything else that isn't underlined can stay the same. And hopefully this will give you a good sentence frame to be able to interpret the IQR in the future. So another way that we can actually measure variability is using something called standard deviation. Now, standard deviation is quite a challenge of steps to find by hand. I'm going to teach you guys how to do it by hand. You're only going to have to do it maybe 2-3 times by hand, and I'm going to show you guys some shortcuts on the calculator. Okay, so standard deviation measures the typical distance of values in a distribution from the mean. So it's the typical distance that each value is from the mean. And to find the standard deviation, which we can call S sub x, of a quantitative data set, by the way, this is S sub x is when you have a sample standard deviation. You might also see SD as a way to represent standard deviation, or you might see a lowercase sigma. Sigma. Remember that the capital sigma looked like this. We actually see it again down here, but I just wanted to let you guys know that that is a lowercase sigma. So this is usually used to represent the standard deviation of a population. We'll get more into that later in other units. I just want you to know that these are 3 different ways that you might see representing standard deviation. So here's what we're going to do. We're going to find the mean of the distribution. That is our first step. And then we're going to calculate how much each value deviates from the mean. In other words, we're going to find the deviation by taking the value and subtracting the mean. We're then going to square each deviation and then add all the squared deviations up, divide by n minus 1, and then take the square root. It sounds like an impossibly long and confusing thing, but you'll see the way that I organize it on the next page. It's actually going to make it pretty easy to do. So if the values in the data are given by x1, x2, x sub n, we can then rewrite the formula for calculating the standard deviation as this guy right here. Instead of me just reading the whole thing, I'm going to tell you that this says we're going to take the square root of the sum of all of the values, subtracting the mean, and we're going to square that. So this right here is the deviations from the mean. We're going to square those, sum them all up, and then we're going to divide that by n minus 1. Again, a little confusing. I think it's going to help a whole bunch when we're about to do an example. So let's do that now. Okay, so example number 11, how close are your friends? Okay, so 11 high school students were asked how many close friends they have. Here are the responses along with a dot plot. Again, I lied. There's no dot plot. There will be some in your notes just in case if you need them, but there's not one here. Okay, so what we're going to first do is we're going to calculate the standard deviation, and we're going to actually interpret that value in context. And what we're actually going to do first is we're going to find the mean of the distribution. So in order to find the mean of the distribution, you can add all of these numbers up. And then we're going to divide, and there's 11. How many are there? There's 11, so your n is 11. So you have 1 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3 plus 4 plus 4 plus 6 divided by n, which would be, in this case, 11. So all of these numbers up here, it looks like they add to 33 divided by 11, which will give us 3. So x bar is equal to 3. It's really good when this number is a whole number. That's not always going to happen all the time, but this is going to make calculations very easy on the next page. So this was step 1. Wasn't that difficult, hopefully, because you guys learned all about mean yesterday. So now we're going to calculate the deviation of each value from the mean. So remember that we know that our mean is 3. Okay, so what we're going to do is we're going to take each value, which is here in this top row, and we're going to subtract the mean. So we have 1 minus 3, 2 minus 3 for all of these. Then we have 3 minus 3 for all of these, 4 minus 3, and then we have 6 minus 3. So this is going to give us negative 2, negative 1, 0, 1, and 3. Okay, so we have now calculated how much each value deviates from the mean. The next step we're going to do is we're going to square each of the deviations. So these are the deviations right here, and we're going to square them all. So we have negative 2 squared, that's going to give us 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. And 3 squared is 9. So now we have all of the squared deviations. Our next step is to add all of the squared deviations up. So we're going to add all of these numbers. So we have 4 plus 1 plus 1 plus 1. That's going to give us 7. All of these zeros still give us 7. 8, 9, 18. So we have 18 as the sum of all of the squared numbers. I'm actually going to write this out real quick. So we have s sub x is equal to the square root of the sum of all of the deviations squared divided by n minus 1. So what we actually just found, the sum of all the deviations was 18. We have 11 numbers, so it's going to be 11 minus 1. And now we're just going to simplify. So we have the square root of 18 over 10, or the square root of 1.8. You can put that right in a calculator, and you're going to get approximately 1.34 close friends. Okay, so the standard deviation to this problem is 1.34. I know it's quite a process. Like I said, I'm going to help simplify this a little bit later with a calculator. So the last thing we have to do is interpret this. So this means that the number of close friends these students have typically varies by about 1.34 friends, close friends. Ooh, let's make sure we get the right wording in here. Close friends from the mean of 3 close friends. Again, we have another sentence structure to help you interpret. The number of context, and then typically varies about, this is your standard deviation, from the mean of, and this is your x bar. So again, the numbers that are not underlined will stay the same every single time that you guys interpret. Everything that is underlined will change based on your numbers and the context. Okay, so the number of close friends these students have typically varies about 1.34 close friends from the mean of 3 close friends. So, what does this number mean? Oh, I just had this. Okay, so things to know about about standard deviation. So standard deviation is always greater than or equal to 0. It's never less than 0. You can't deviate because we square everything. It will never be less than 0. S sub x is only equal to 0 when there is no variability. That is, when all the values in a distribution are the same. So if we had a distribution 1, 2, 3, 4, and every number was 3, well then obviously here the mean would be 3, and nothing deviates from that. So the standard deviation would be 0. So larger values of the standard deviation indicate greater variation from the mean. So another example of that would be, let's say we have 1, 2, 3, 4, 5, and we have the mean, and then we can have things further away from the mean. Okay, so this actually has a pretty large distribution, standard deviation, instead of something that looks like this. You see how everything here is close together? These ones are more spread apart. So the standard deviation is larger in this one compared to this one. Another thing you need to know is the standard deviation is not resistant to outliers. The use of squared deviations makes the standard deviation even more sensitive than x to extreme values in the distribution. Remember that the standard deviation measures the variation about the mean, and we actually use the mean when we're finding and calculating the standard deviation. We already know that the mean is not resistant to outliers, so it makes sense that if we're using something that is not resistant to outliers in a new formula, then it makes sense that the standard deviation is also not resistant. So there's a couple things you need to know. We use the median and IQR in distributions with outliers or if they're skewed. We use the mean, and standard deviation in mostly symmetric distributions. So and this is a very, very important note here, if you have a very skewed distribution or a distribution with a lot of outliers, because the median and IQR are resistant to outliers, we use those to measure center and spread. If it's roughly symmetric and there's nothing crazy going on, we'll use the mean and standard deviation as your measures of center and spread. And that is actually all we have today for notes. As always, you guys can email me if you have any questions, and I hope you guys all have a fantastic day.